Okay, so this week the idea is to cover 3.7 and half of 3.8 at least. So that's the chain rule and part of the applications like finding the derivatives of inverses like logarithms and inverse trigonometric functions and such. So that's the idea. And also implicit differentiation, which is possible because we know the chain rule. But let's not get ahead of ourselves and start with just 3.7. Okay, so that's the chain rule. And so what's the idea here? We have already derived some rules for differentiation, which tells us to know the derivative of a function if it's a product of two other functions for which we know the derivatives already. That's the product rule. And it's a basic rule which allows you to find the derivative of f plus g if you know the derivative of f and the derivative of g. And which only amounts to take the derivative of each one and add them together. Okay, but and so that is already enough. I mean, for us to know the derivatives of many functions, and you did that for the first exam. For instance, products of exponential and exponential e to the x and some polynomial divided by another polynomial or some exponential function, but it has to be the form e to the x. Very soon, once we have the chain rule, we'll be able to compute the derivative of a to the x, where a is some positive number. And also, yeah, now that we know the derivative of sine and cosine, tan and cotan, we'll be able to find, I mean, to derive the formulas for the derivatives of arc sine, arc cosine, etc. So what is this chain rule? So first of all, let's try to recall what a composite function is. So this is a function of the form. This is a function of the form f. So it's f composed with g, evaluated x, is computed by evaluating f at g evaluated at x for every x. So that's a composite function. It's a function, so it's is a function of the form and examples. Suppose that f of x is just e to the x, and g of x is x squared. What would f composed with g at x be equal to? This is simply, well, we have to realize that we have to evaluate. I mean, we have to start from the outside and work our way to the inside. And what is f of g of x? Remember that f is e raised to the power of the x that is inside the argument of f. So this is what we're going to be doing. So e to what's inside. So that's g of x. And now we'll see, well, g of x is just x squared, so this will be equal to e to the x squared. Very good. So now this gives us one example. It will be example 1, example 2. What about, I'll say, f of x equals sine and sine of x and g of x equals square root of x squared plus 1. Then what is f composed with g? Well, again, we follow the rule. We go from the outside, so f is the outside function. So we compute f of g of x, which is sine of what's inside g of x. And what is g of x? Is square root of x squared plus 1. So this is f composed with g. One final example, because I mean the rule the chain rule we're gonna apply perhaps ask us to find the derivative. I mean, for some applications we'll be asked to find derivatives of compositions of functions that involve more than two functions, like three functions. For instance, what if I give you f equals cosine of x, g of x equals e to the x, and h of x equals, again, we're combining everything we've done so far, 1 over x plus 3. Then what would f composed with g composed with h at x be equal to? Again, we know that we need to compute f evaluated at g, evaluated now at h of x. So we start from f. F is cosine of what's inside, so this would be cosine of g of h of x. And now we can concentrate on g. What is g? G is e to what's inside, so we e to the h of x, because that's what's inside g. G of x is e to what's inside of the argument of g. So in this case, it's h of x. So we're simply writing what this is, which is just e to the h of x. So now, what is h of x? H of x is 1 over x plus 3. So this will be equal to 1 over x plus 3. And this is our final answer. Okay, having said that, we move to our next point. Theorem 1. Which is the chain rule. If f and g are differentiable, then the composite function f composed with g evaluated at x, which is the same as f evaluated at g of x, is differentiable. Is differentiable. Okay, so this means, I mean, we did, just by knowing that f two functions f and g are differentiable, whenever you consider the composite function, then that's going to be differentiable. But most importantly, this is what the rule is about. It tells you how to compute the derivative of this composite function in terms of the derivatives of f and g. So the derivative of the composite function is f prime evaluated at g of x. So you need to compute the derivative of f, and once you know the derivative of f, you plug in g of x inside the formula, and then you multiply by g prime of x. Okay, so this is the chain rule. This is what the chain rule tells us. Okay, and this is the last of the rules we'll need in order to find all derivatives that are going to be known to us until the end of the semester. Okay, so let's try to, we'll do the first example, we'll do a few examples. We'll start with the easier ones, and we'll do the first ones in a lot of detail, but after that, I mean, we'll just skip some steps because I hope that you become more familiar with this kind of problems, and so you don't need to waste time, especially because you're going to be taking exams, so you don't want to be wasting time on unnecessary steps. So y is the function y of x, which is given by sine of x squared. So what would y prime be? Well, what are the two functions here? There's one function which is f of u, which is sine of u. This is the outside function. And there's an inside function, u, which is going to be g of x. Which is just equal to x squared. And this is the inside function. So according to the formula, well, and it's easy to check here. If we plug g of x in here, what we get is a sine of x squared. Okay, so this is what we're using here. So, but according to the chain rule, if we want to differentiate y, we need to compute f prime and evaluate it at g of x, and then multiply g prime of x. And that will give us the derivative of y. Now, what's the derivative of f? F prime of u is the derivative, is sine prime of u, prime evaluated at u. So you want sine u prime. And we learned that last week, so this is cosine of u. And what is g prime? G prime of x is, well, this is the power rule, is 2x. Okay, so now using this information here, we get that y prime will be f prime. F prime is cosine of, and what we put inside is g of x. G of x is x squared. This is g of x. And times g prime of x. G prime of x is just 2x, and we just put it in here. Alright, so then what about the next example? The square root of e to the e to the x divided by x plus 1. Okay, so now this is again a composite function. And what is the outside function? F of u is simply the square root of u. We're computing the square root of some expression here. And what's inside the square root is the inside function, of course. And that's e to the x divided by x plus 1. So how do we find y prime? Y prime is, according to the chain rule, f prime evaluated at g of x times g prime of x. Okay, but what is f prime here? F prime of u is, again, this is the power rule. It's with u to the 1/2, so this gives us 1 over 2 times the square root of u. And what about g prime? We can compute g prime of x already because we know the quotient rule. So this is just e to the x times x plus 1. Remember, it's the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, which is 1. All of that divided by 1. And this is equal to, well, you see that if you expand here, the e to the x times 1 and this e to the x times 1 here cancel out. These are e to the x's both, but I'm just making everything very explicit. This is 0, and this becomes x times e to the x divided by x plus 1. So we have everything we need to compute this derivative. So f prime is 1 over 2 times what's in times the square root of what's inside of f. 1 over 2 times the square root of what's inside of f, which is g of x. G of x is e to the x divided by x plus 1. Okay, again, f prime is 1 over 2 times the square root of what's inside of f. In this case, what's inside of x is g of x. It's g of x. But g of x is e to the x over x plus 1. And now we need to multiply all of that by g prime of x, which we computed here, which is x times e to the x over x plus 1 times g prime, but g prime is x times e to the x over x plus 1. And here actually I made a mistake here, because when I apply the quotient rule, this is supposed to be squared. Okay, so sorry about that. And so in my final answer, I should get x plus 1 squared. Okay, so y prime is equal to this expression here. And that's, yeah, so those are the first two examples of the chain rule. And we'll continue with some more examples. But we will try to make the point that the most important thing about the chain rule is to apply it to solving some problems. And yes, I mean, so that's what we're gonna be doing then soon after. And all the applications are or the important applications are contained in section 3.8, which we'll try to get to kind of quickly.